Hello guys, welcome to day 4 of our 75-day lead code coding challenge. Today we are going to solve our fourth problem statement, can place flowers. So let's start. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Given an integer as a flower bed containing 0 and 1, where 0 means empty and 1 means not empty, an integer n. Return true if any new flower can be planted in the flower bed without violating the no adjacent flower rules, and false otherwise. So basically, let's try to understand the problem statement. So this one is empty. Suppose you have n flower pot. You have n flower pot, and there is an existing bed. Let's call it x1, x2. There is an array of elements that we call it as a flower bed. So we need to place these n flower pot like that it do not violate adjacent rules. So what is adjacent rule? It means if there is a pot in the middle, the left side and the right side should be empty. So this is the valid flower pot because in the middle, the left and the right side is empty and there is no adjacent pot. And similarly, this is invalid pot, invalid flower bed, because we have two pots that is adjacent to each other. Similarly, this is a valid flower bed because no two pots are adjacent. Similarly, these flower beds are not valid because two flower pots are adjacent. So simple logic is, if left seat is empty and right seat is also empty, then we can place new flower pot, right? This is the equation. If left seat is empty and right seat is also empty, then we can place new flower pot, and you have n new flower pot. So you need to place these n flower pot, and you need to return whether it is true, whether it is possible to place this n flower pot, then we return true, and if it is not possible, then we return false. Okay, so suppose let's take our first test case. You have this flower bed and you have n equal to one pot in your hand. You need to place this one pot like that you do not violate the adjacent rule. So you start placing and you see, right, you in the middle you can place that flower pot, and this is the valid flower pot. So the answer is true. You can place your pot, and it is still the valid flower bed. Now take it another test case. What if I make n equal to 2? Then there is no sequence exist where you can place both pot and it will remain a valid flower bed. Suppose if I place two pot here, then it is not a valid flower bed, or even if I place here, it is not a valid flower bed. So the answer is false. It is not possible to place both pot. Correct? So now let's delete this thing and write our logic how we are going to solve this problem statement. What we can do, we simply can iterate first, iterate over the flower bed, then simply place your pot if left and right side is empty. Correct? And last, check if all the pots in your hand is consumed. So basically, we are going to follow these three steps to solve the problem statement. First, we are going to iterate over the flower bed. Then we're going to see if the left for every index, the left and the right side is empty. Simply place your pot. At the last, we will check if all the pots in your hand is consumed or not. So now let's write the code. So first, iterate over your flower bed. I equal to 0, I less than flower bed dot length and I plus plus. There is one edge case also that we need to consider. For first index, there is no left element, and for the last index, there is no right element. So if this is like this, 0 and 0, and n equal to 1, then we can place at first position also, and we can place at the last position also, right? So we need to, so for the first index, we only need to check the if the right side is empty or not, and for the last index, we need to check if the left side is empty or not. So yeah, let's follow this logic. So first, we are doing defensive check if I plus 1 should be. Before that, let's create two boolean. Is left empty? Let's assume that it is 2 initially and create another element. Is right empty? Let's assume it is empty for now. Then we add the validation check. If I plus 1, I minus 1 should be greater than equal to 0. Basically, this is for first index. This tag is for first index, that is should not go index out of bound error. And if our left side is not empty, basically one, there is a pot on the left side, we simply mark our left side is not empty, right? First we assume it is empty, but now we are doing the validation check. Similar thing we can do for the right side. If our right side should be less than flower bed dot length. This tag is again for the last index and this is for the first index. If the right side already have the port, we simply mark our right side is not empty. Then we can say if our left side is empty and our right side is also empty, let's place a pot there at that particular index because our left and right side is empty. And also one pot is consumed, so we are reducing the n, the pot that are in your hand. One more corner case we need to pick. If all the n is consumed, your n should not go into negative direction. So if as soon as n equal to 0, break the for loop. Another case is we do not need to do this processing when there is already a pot at that particular index. So if any pot exit at that particular index, simply skip that particular iteration. At the last, we will only check if our n is equal to 0 or not. And let's comment this part and try to run our test cases. So yeah, our test case is running. Now let's submit this problem statement. And yeah, it is working. So yeah, thanks for joining the session. Let's meet tomorrow.